Alright, we've talked a lot about levels of indirection and what the pointer scanner does. What does the pointer scanner do? It collapses levels of indirection. How does it do that? Well, because it knows what a pointer is on an implicit level, and it sort of, collapses it down in ways that we've talked about. As you can see, I was watching that previous video, sort of to figure out how I'm going to approach this. So, but is there a coherent plan that I'm following for how to find the video and whatnot for us screwing around? As I said before, kind of making it up as we go along. Is this even possible for us to find the pointer value relative to this process for the first variable? I don't even know. Um, you know, again, some people out there maybe just watching us or watching me go through this saying, you're a complete fucking retard. That's fine. We're gonna keep going anyway. So new scan. Just to be safe, we're gonna close this all down. Close the interpreter. Close that. Start from blank slate. Still making the same joke. Still kind of funny. Bring up Notepad. What do we got? Pointer trick. Pointer scan. You can see I kind of typed in a little bit of crap here. Pointer trick of Python. Use the pointer scan to abstract away a few details. Yep, sort of talked about that. Find the offset relative to the memory process that points to the first declared variable. You can see I'm kind of formulating the idea here. What do we got? We're going to mess with the value to prove that this first theorem or first axiom or whatever you want to say is correct. We're going to delete the variable. We're going to recreate the variable. We're going to make sure the value is correct. Then we're going to exit the interpreter. We're going to restart it. We're going to exit it. We're going to exit the interpreter. We're going to restart the interpreter. We're going to check the value of the variable. Then we're going to come back down here. We're going to repeat this process. We're going to exit. We're going to restart, check the value, exit, restart, check the value. We do that probably, I don't know, a couple times, something like that. But you can see there is sort of a game plan here. Have I tested this? No. So picking up where we left off. Let's quit screwing around. Do this. Python. We've talked about the pointer scanner. We know what the pointer scanner does on a conceptual level. Minimize this. Bring up cheat engine. Again, are we going to make a fool of ourselves? It's possible. Do I mind making a fool of myself? No. Correction, yes. I do mind making a fool of myself. But just as long as people that want to offer me a job are not watching. So, in that context, I don't really care. But if anyone, who happens to, maybe be offering me money to do some things is watching this, then I absolutely know this is going to work. And there's no doubt in my mind. I totally know what I'm doing. And this is all just cheese as far as I'm concerned. So, anyway, getting back to the real thing here. What are we doing? We're going to make a variable. Why are we making a variable? Because we are going to declare the first variable relative to this, we're just going to declare the first variable in this Python interpreter. We're going to give it some value. Shit, we already screwed up already. We don't want to do that. We're going to restart it. We want to give it some bit pattern that is going to be immediately recognizable in Python. So we only get one result. So we're gonna go. We're going with funny variable names now. We had Bugs Bunny. We could do Daffy Duck or something like that. I don't know. What's something we do? I have no idea. We'll go with. Oh no, it's the NSA listing. We'll go with Chairman Mao equals. It doesn't really matter. He's gonna equal elite. That's what that means. We haven't attached the process because we're being stupid. Yep, second one. First scan. Do we get one value? We do. Alright, that's good. That's great. Let's check the, make sure we have the right value. What is Chairman Mao equal? According to Python, it is in fact 5. Let's make this value, I don't know, 125. What does it equal now? Just go back to the screen, hit up. Unfortunately, it doesn't have that feature, so tab. No, I definitely don't want to do that. Chairman Mao. 125. Alright, great. Proven that these two applications are in sync. So what are we going to do? We're going to pointer scan. As we talked about, what's the address we're finding? We're finding this address down here. It's auto-populated. What does this address mean? We talked about what that means, and I'm really not going to beat that to death. If you want to know what it means, you can go back in the previous videos, but God knows we've talked about indirection and things like that. We're ignoring this white box for now. Number of threads, we're going to leave it at 5 so we can sort of just, deal with the no spurious results, deal with the default value. Max level, we're going to change, or we're going to leave that to 5 because, whatever it's set to 5 for a reason. We're going to hit OK. Let's delete all these things. These things will certainly not exist if you're doing this for the first time. This is just, I have done pointer scans for other applications and whatnot. Let me see if I can undo that. Undo, delete. Yeah. What do we got? 421. I'm not even sure that the first video as far as this was recorded at that time. So just in case anyone thinks I'm totally bullshitting here, I mean, I was pointer scanning Shadowrun.exe and things like that. So anyway, we're going to delete all this crap so that we just have sort of a fresh directory here. So what are we going to start? I like to start at 1 or 0. I happen to be 0 based as far as indexing. Can I type 0? Thank you. So we're going to type 0. What does this mean? This is the base pointer scan that we're going to do. We're going to have to go over this in a couple steps, and we'll see why that's necessary in a little bit. But when I'm doing my absolute first pointer scan, and I'm literally scanning the entire process for some value, some address, as the case may be, I like to name it 0. So we're going to name it 0 so that we know that this is the absolute root. We're going to hit save. This is going to take a little bit. So the larger the application that you scan and the more levels of indirection that you're scanning, the longer this is going to take. For us, I'm going to guess about a minute. It might be a lot faster, but what's the file name? We're not going to bother with extensions or screw around with any of this stuff or anything like that. We're just going to say the file name is 0. We're going to hit save. It starts doing its thing. What's it doing? It is scanning memory values. No, it is scanning memory locations for values that refer to other memory locations. And it's doing that on 5 levels of indirection. And it's scanning for this address. So, maybe if we increase the max level of indirection to 8, would we see 8 threads down here? I highly doubt it. I think that maybe, we'd have to sort of, we would, as logic might imply, we would have to increase the levels of, or the number of threads that we're running for this process. But as the case may be, it finishes. Before we talk about this, how many values did it find? Let's see here. 14,213,842. That is I'm not even going to bother making up some kind of crazy metaphor about what that means, but that is a totally unmanageable set of results. We're clearly going to have to whittle that down, going through them and dealing with, hey, well, this looks like the right value. I mean, that's just absolutely absurd when you're talking about 14 million values. What is Cheat Engine saying? It's saying, you know what, I'm only going to give you the first, let's just make sure we're not talking about, yep, the first 1 million values, or entries as the case may be. And, when you start dealing with stuff from, after the 1 million values, you're pretty much on your own. Basically, what Cheat Engine is telling you is you really got to come up with some kind of constraints relative to the application that you're scanning to get this below 1 million, or I'm just, I'm not doing you any favors, and you're pretty much on your own in that regard. So how are we going to do this? Well, we're going to think about this. Let's do we want to change the value in here? It's going to change the memory location, so it's going to change the value of the pointer. We're not going to do that yet. We're going to change the value here in Cheat Engine. This will be this sort of dynamic between the application and Cheat Engine will be much clearer when you're doing this with games. But there is some sort of subtlety that I'm sort of abstracting away and dealing with here. But we again, if this works relative to the Python interpreter, we are proving this. Just again, there's people out there saying you're just full of shit. Get rid of that. We're gonna make this 25. So how are we gonna filter this down? Let's make sure. We're gonna ask Python here. What do you think about the variable chairman Mao? It has a value of 25. That's exactly what we want. See, you can see the values over here have actually changed to 25. What do what do all these pointers point to relative to something in memory plus some offset? Let's see if we can expand this a little bit. Yep. We'll leave that out there. The offsets, whatnot. What is it relative to? It's relative to something. We got a lot of DLL files and PYDs. We'll talk about that in a little bit. But then there's some serious offsets going on over here. plus some other series offsets, and then what does it point to? Well, it points to some location in memory, which you can see is reflected in the address that we have down here, 229.5188. Same thing that you get over here. What are we looking at here? Well, what Cheat Engine and the pointer scanner specifically is telling us is I have something in memory named Python27.dll. There's some absolute address in memory in the computer's RAM that represents this. Then there's some huge offset that I'm applying to it. There's some other series of offsets or whatnot that I'm applying to whatever this is, whatever the first base address is. And what the value of all this series of indirection is this, and the value, once I dig into this memory location, is 25. If we change this to 33, you will see that the majority of these will in fact change to 33. There you go. It's instant. It's Ask Python. What do you think about Chairman Mao now? In fact, it thinks that it is 33. So how are we going to filter this down? It's really quite simple. We are going to use we're going to search by value instead of having to go back and restart this or restart that and screw around and all kinds of things. So we have control. Again, this is the whole reason we're using Python. We have control over the value of variables in Python in a way that we normally don't have as far as an application. We can literally just, jump into the Python interpreter here, do anything we want to this value. We can, even we could reassign some value to this variable, and that would change the address, and that's something that we're going to do in a little bit. But for now, we're just going to focus on the value on the far, 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 far right side of this. All those levels of indirection. There is some value, some constant. It is 33. It is now 55. We will ask Python. So how can we break this all down? We can do it really, frankly, quite simply. We just simply ask the pointer scanner or cheat engine, whatever you want to say. We simply say, check all these levels, check the 14,213,842 pointers that you found, and check all those, go through all the memory indirection and all the accesses and things that you have to do. And once you finally get to the end of all that, check the value, make sure it's 55. And if it's not 55, then get rid of it out of this big list. So how we do that? Well, it's limited functionality as far as the pointer scanner is concerned, and that's a good thing. So, can we right click on this stuff? We can. What's it say? Resync module list. We're not going to worry about any of that. It's a very limited option, somewhat obscure. Go up here and tell, how do we want to chirp these values over here on the right. You can see they change. We're not going to deal with any of that. For now, we're just going to say they're 4 bytes. So a whole lot of technical mumbo jumbo involved with that. But we go to File, we go to New, we go to Open, in case you want to backtrack, pointer scanner, things like that. We go to pointer scanner. Are we going to go to scan for pointer? No, because we've already scanned for the pointer. We've already sort of established the hierarchy, if you will, of indirection that exists in this application. So we're going to go to rescan memory. What does rescan memory do? Well, it's telling us right here. It removes pointers not pointing to the right address. Now, that's a little obscure in the sense it removes pointers not pointing to the right address. What is that? You can scan for the value on the far right over here, and that option is not immediately obvious that you can do that. And also, it's not immediately obvious just by clicking on the pointer scanner here that it's going to sort of go back down through the levels of indirection. But it's sort of an implicit, implied thing. But for our purposes here, we're going to say that when we go back up here and we click on rescan, there are going to be options that are going to allow us to specify I only want to look at the right side, the far right side, as far as the constant value located in all these levels of indirection, and I only want to look at I want to go all the way through these levels of indirection. I don't want to I don't want to stop at the first level. I don't want to stop at the third level. I don't want to stop at the fourth level, and whatnot. I want to check every level of indirection, and I want to go all the way to the right side of the equation, as the case may be, and I want to look for a value there. And so we will dive right into that immediately as soon as we come back.